Hello, everybody. I'll stay here because it's there is a light over there, and I cannot actually see you if I go there. So first of all, thank you for coming, attending my session. First of all, a few words about me. My name is Dimitar, and I'm coming from Bulgaria, which is like over there. And I know I can tell you a few Turk, like I can tell Merhaba komşular. So what I do software development for the living, and I am also a Kanban practitioner. I am a accredited Kanban trainer and Kanban coaching professional. Also, well, for this conference, I'm a software development, so that's important. So I'll try to show you something which I hope will be practical advice for you, something that will help you solve, hopefully, problems that you have and gaps that you need to fill. I'll try to speak as slow as possible because I know that for all of us, English is not our native language, right? But that's it. Unfortunately, I cannot talk Turkish, although I would like to, but it's if you find me something like to do in Turkey on a regular basis, I promise I will definitely learn the language. So that's a promise. Yeah, komşular, I know, yeah, yeah. Komşular, arkadaşlar, you know, so it's okay, so who has read these books? Anyone? At least one of the books? No? Anyone? Okay, so for for the rest of the audience, this is Steve McConnell. Steve McConnell was really a very, very big figure, like in the 90s, like last century. And that's why I started my professional career in software development. So I'm 45 right now, actually 46. And Steve McConnell has this very important book I recommend, highly recommend to everybody, like Code Complaint and also Rapid Development. But Steve McConnell is still a big figure in United States in the software development. And in regards our topic, that's what he has like this thought, right, from an article from 10 years ago. So he says that true agility, and true agility for Steve means adopting a posture that allows you to respond rapidly to changing market conditions and customer demands, conflicts with predictability. So if you are agile, you cannot be predictable. If you are predictable, you are not agile. And here is another set of books. Anybody familiar with the books? Okay, so who is the author? The author is Martin Fowler, who is much more famous than Steve. And here is what Martin actually has tweeted some time ago. So he says that IT organizations need to govern for value over predictability, responsiveness over cost efficiency. So again, we have this dichotomy, value versus predictability, responsiveness versus cost efficiency. I guess it's the same, like the same context. So here predictability means something which is very dry, very much like for accountants, cost efficiency, something like that. And why is this topic important for us as software developers? Because we have to actually satisfy our customer demands. Like I'm in custom software development, so my company develops software for clients. And first some definitions, like what is adaptability? This is the definition I believe everybody can share. Adaptability is the ability of a system to adapt to changing market conditions and customer demands in order to be better fit for its purpose. In other words, the system can take different actions in different local conditions. So that's to be adaptable, right? And then predictability is the degree to which a correct prediction of a system future can be made. So these are the working definitions for this session, okay? So again, why is this topic important to us? It is a equation that I learned from McKinsey years ago, and that's how they actually work. McKinsey is a big consultancy company, right? And here the topic, what I will try to present to you is how actually to show your clients and your managers, if you have managers, that indeed you are agile, right? And here is this equation which says that customer satisfaction equals performance minus expectations. And today we will talk about this part, the expectations part. What people expect from an agile team. How does an agile team look like? From the outside, not from the inside, okay? From the outside. So, and that's the question. How can you show to your managers or project sponsors that you are agile? Assume you have this line on your website that we do agile software development, we are agile, we are everything. So how can you actually show it? So this is like an example project. And my question to you is this project agile? So what we have here, this is, some people call it burn-up chart, but we in Kanban call it cumulative flow diagram. What it shows is like on the x-axis, we have the timeline for the project. It started here, and like it's month, several months. And on the y-axis, we have the number of user stories delivered. And it's cumulative, right? So we see that initially, the number grew very slow, and then somehow it started like very fast, okay? And eventually 200 and something stories were delivered. So is this project agile? If you look at it, like it's not agile, right? Why it is not agile? Why? It's not a rhetorical question. That's the topic. Why it's not agile? Because it has this curve, right? It's not straight line. And why do we expect that an agile project has to have a straight line for burn-up chart? Why is that so? Yeah, I claim that because I ran this project 7 years ago, I know that it was an agile project, and at the end of the talk, I hope I'll show you that indeed it was. But from outsiders, from management point of view, from project sponsors point of view, that's not a predictable adventure, right? The team initially did no work at all, okay? No work, it looks like no work at all. And then somehow they decided to start working, and eventually they finish it, right? With probably heroic efforts, like they are some kind very bad experience, right? Heroic effort, right? But that was not the case, right? So that's an illustration why people conflate, which means they, like in English, conflate, I hope you know what, like, of course, English is not for all of us, native language, but they conflate predictability with adaptability and agility. Just like Steve McConnell would say, this was not an agile project, right? Because it was obviously unpredictable, right? So we will look to predictability and adaptability from complexity science perspective, okay? A bit of science, but I'll try to have it very short. So from a complexity science perspective, well, in the world we have 3 types of systems. First of all, we have ordered systems. In ordered systems, we can predict the future based on past history. There are constraints and rules that allow us to do so. In chaotic system, everything is random. And because it's random, we actually can predict the future, because we have statistical, mathematical instruments for doing so, right? The difficult part here is the complex system. So complex systems are neither ordered nor chaotic. Usually, when I have to provide like analogy, what a complex system look like, an ordered system would be a ice. Ice is an ordered system, right? It is so thick, nothing changes there, right? Chaotic system would be gas, right? When the ice actually melts down, it will, when the temperature goes higher, it will become like a gas. And the complex system is the water, right? The water can do different things. The water can actually move. The water can destroy stones, for instance, right? We know how water can be very dangerous, right? So that's an analogy, okay? So it's an analogy. Oh, and then, yeah. And then in this, the complex space, we have this thing called complex adaptive systems. And complex adaptive system consists of many components which we call agents that interact, adapt. They interact with each other and they interact with the environment. They adapt to the environment. And this adaptation can be actually looked at as learning. Like, so they learn how to live in a certain environment. And these are the characteristics of a complex adaptive system, or CAS. So first of all, it acquires information about its environment and in its own interaction with the environment at a certain level of granularity. Granularity means like time-based or anything like that. And then, based on this information, the system identifies patterns, regularities from the interactions, and it will store the regularities, but not like a lookup table only, but it will create patterns for different cases. The system will create patterns how to behave in different cases, okay? And then the result obtained by using these patterns in the real world will feed back in the system as new information, and based on this new information, new patterns may be actually created. So that's very, very familiar for all of us because we work in a complex adaptive systems all the time. An example of a complex adaptive system is a team developing software for a client. And I hope you can actually find similarities in these three activities that a team developing software for a client actually does, right? For a new client, especially for a new client. And human complex adaptive systems are different because they are ant nests, for instance, ants. They are complex adaptive systems. They build ant nests and they have organization, ants, right? But they are not like humans. Because humans, we have many identities. We are not only software developers. We might be fathers, mothers, relatives. We might be anything like hobby, many, many identities. Then we have intent. We have a goal or goals from time to time. And that makes a human complex adaptive system very difficult to actually model and predict. And that's why Mary Gell-Mann received the 1969 Nobel Prize in Physics for the invention of the quarks. It's quite old, actually, invention. And he said, that's famous line, that the only valid model of a human system is the system itself, which I believe aligns very much with what we have in Agile, right? If you look at the Agile manifesto, that's what actually it says, right? Interactions over anything, like, you know probably the manifesto. So it's very much aligns, although it is from 2015. Actually, he worked in this field for 20 years, so it's not something new, but it's a good line. So what we as humans are capable of is we are capable of shifting system from complexity into order and maintain it there. Again, shifting from complexity into order and maintaining there. And that's what actually we usually try to do in our daily lives, okay? We want to find some ways that will make our lives predictable, less stressful, less complex, okay? And as a complex adaptive system adapts on two levels. So first level is when it actually works or behaves in a real world as prescribed by its own set of patterns. So we have a pattern, we apply the pattern, we get the results, we like the results, we continue applying the same pattern. And then on the next level, a complex adaptive system may actually decide to change an existing pattern or maybe create a new one because the environment changed. And for such systems, what's important, they want to actually not only survive, but they want to thrive, which means getting better and better and better, even better and better. And in order to do that, they have to be sure, there must be confidence that the system will be able to adapt. And that's why the name of the talk, like they have to be predictably adaptable. We have to be sure that the system will adapt, definitely will adapt to the changes in environment. If we have a software development system, like I do, when we have a new client, we would like to be sure that we will adapt to the new client. If we have a new technology to work with, we have to be sure that we will be able to adapt to the new technology. And in software development, it's on a daily basis, we have something new to adapt to, right? At least in my experience, right? So this is all. It might look as if we are going away from the topic of the talk and the initial project burn-up chart, but that's actually, we are going in the proper direction. And here, next question is, if we want to know, to be predictably adaptable, how actually we can do this? For this, we will be using the Cynefin framework. Cynefin is a lens to show us actually how to find our way around complex problems. So Cynefin framework is about sense making. And the formal definition of sense making is that, and I'll read it, sense making is the way humans choose between multiple possible explanations of sensory and other input as they seek to confirm their perceptions with reality in order to act in such a way as to determine or respond to the world around them. But in short, it says that sense making is the way we humans make sense of the world so that we can act in it. We make sense what is going on so that we can act according to our goals and our intentions and our identities, okay? So how can we actually make sense of the world? And again, here so Cynefin, first of all, who is aware of Cynefin? Hopefully some, yeah, because I don't want, oh no, okay. So for everybody else, Cynefin is a Welsh word which means something like habitat, right? And it's the name of the framework. It is invented by Professor Dave Snowden. I strongly encourage you to go to YouTube and Vimeo and just type Cynefin, and you will find many videos and stuff explained very much and from many people, including Professor Snowden. And Cynefin actually help us make sense of the world around us. That's its goal. And it is first about contextual awareness. Contextual awareness means we have to understand the context we are in, to be aware of it, and then based on the context to act accordingly, okay? And Cynefin defines the context, all context, the world actually, in 5 domains. So we have 1, 2, 3, 4, 5. The 5 domain is in the middle. And here at the bottom we have this fold, which is about to show that from very rigid environment we can get into chaos quite easily. But first about domains. So first domain, the right-hand domains, the obvious and complicated, are the domains of order, and the left-hand side domains, complex and chaotic, are the domains of unorder. It's not disorder, it's unorder. So there is no order. And the ordered part of the context is divided into obvious and complicated. Obvious are the contexts and situations or problems where we have very strict constraints or rules. For instance, how we drive car on the street. There are very rigid rules, to the point that we can actually drive a car and have a conversation, okay? Very rigid rules. Like here, we have so-called best practices. Best practices is something that in a certain situation we must do. That's the best practice, okay? And if we are aware, if we know that we are in this type of situation, what we should do? Remember, we have to first understand where we are and then take an action. We first sense what is going on, then we categorize, which means that we take the situation, we look for a pattern or a best practice, and we say, well, in this situation, we respond in such a way. So that's it, sense, categorize, respond based on best practices. Then the complicated domain is the domain of experts. Here we have rules and constraints, but they are not rigid. They allow for some flexibility. That's why we need experts, because experts, they have knowledge, a lot of knowledge, and they can actually analyze the situation and give us some good practices to follow, but not a best practice, okay? So here, when we know that we're in a complicated situation, what we should do is first sense the environment, and then we analyze it, and then we respond to it, based on good practices. So what's important? So in software development, majority of the work that we do this work in the complicated domain. That's why we are experts, right? At least we try to be experts in software development, in interactions with clients, with business analysis, and everything like that. And then there is this complex domain where actually it's called unknowns. And it is a situation where we cannot predict the future, because if we change the initial conditions, the outcome will be different. Every time, the same situation, right? If we start from a slightly different initial conditions, the outcome will be different. The history is important in such context because whatever we do, it is path dependent. If we start from point A, we will reach a different outcome if we start from point B. This type of systems, they cannot be reverse engineered. We cannot go like backwards and say, well, based on the outcome, we will actually find the initial conditions. This type of systems, we have something which we call retrospective coherence, which means we have a project, let's say a software development project, and we work for months and months, and eventually we achieve success. And when we look back, we say, yes, we achieved success because that happened, and that happened, and that happened, and that happened. But we were not able to tell it from the start. We have to actually finish it in order to actually to see how we have achieved this, right? So order here emerges from the interactions by the agents with the environment, and the agents and the environment co-evolve. So the agents change the environment then feedbacks and changes the agents and stuff. So this should actually sound like a software development, okay? If we, at least to me, and I hope I will be able to actually communicate this to you, it's the majority of the work that we do, especially when we start a new project or a new client or a new technology. We do something and the environment changes, and then because the change, we have to change what we do, and then the same thing and the same thing. And here, the way we act, and it's nothing new, it's just describing what we do. As humans, we first probe. Probe means we do some experiments, we test different approaches, and then based on the results, we sense the results, and then we respond accordingly, which means the approaches that actually were favorable to us, we continue in this direction, and approaches which actually were not favorable, we just dampen them, right? We abandon them, okay? And chaotic systems, from time to time, we do have such type of systems in software development, but here, because everything is random, what we have to do, we have to actually first act, do something, anything, so that we at least establish some rules and some constraints, and then we sense the result and then respond. So here is we have to act. It's not about thinking, it's not about probing, and it is usually what we call firefighting, okay? We have to do something, right? And getting back to our problem, right, to software development, here, how to apply Cynefin in the context of a new project, where we have to negotiate what we understand, our understanding and the understanding of the client, right? And that's the picture I put, but it's not all at the time, but it is more or less most of the time, right? So that's us and that's the client, and we try to actually negotiate what actually the outcome is supposed to be, everything around the project, right? And this is called contextualization. So we are in a situation which we are not quite aware, and we have to understand the context we are in, right? Which means we have to adapt to a new context. And the value of this, so what we'll be doing, we will be creating a Cynefin framework for this particular project, because we have to understand the context, okay? And the value of such a framework is that it allows us to have a shared language with both sides, the client and the software development, to understand where we are, what's the context we are in, and why we will take certain actions, and the client to approve that indeed that's the right action to take. Okay? So the client context has three cases, right? Depending on the from a Cynefin framework perspective. First case is if the client knows exactly what they need, and they have it already defined. That is the obvious domain, right? Something really clear to them as a requirement, right? And then the next case is the client, they know what they need, but not exactly. So they have some requirements, some ideas, and they may say, well, we like it something like a certain website or a certain technology, but we are not that sure. And then we as experts, we have to actually intervene and help the client to get it, to have it much clearer, okay? And then the next case is that the client has absolutely no idea what they want. They just have a word as their requirements, as one requirement or just one sentence, and they need 6 or 9 months software development in order to deliver this sentence, okay? So in this case, they just have no idea what they need. The thing is that because they cannot explain we cannot analyze, right, anything. And then how we do it in practice. So we have a whiteboard, and we write these three contexts in the corners, right? Here the client knows exactly what they need. Here they know, but they are not quite sure. And here it's the complex part where they have no idea what they need. Okay. And what we do, first of all, we have a set of user stories, and we write the user stories on index card, on sticky notes. And we put each of the user stories on the desk according to these three corners, okay? And I put, so this user story is supposed to be like kind of this type. So it is not exactly clear. It needs some analysis. And this one, it's absolutely not clear. We have to do experiments, okay? And we place all the user stories on the board, and they are, and there are 13 of them, or 14, okay? And these are the requirements placed along according to the Cynefin framework domains, more or less. And then we try to actually make it clearer the borders between the three domains. And we draw the borders just like that. And it means that this border actually separates everything which is complex, which actually needs some experiments. Here, this border separates everything that needs analysis. And here we have something straightforward. We just start and work on it, no thinking. We know what to do here. It's straightforward. And then we have cases where actually they're on the line, right, or in the middle. So in the middle, it means we are not sure where to put this requirement, or when it's on the line between two domains. And what we do, we move it, we split it in in two or more new user stories, and move it so that we can actually make sense of this particular user story. Does it need analysis? Does it need experimentation? Or does it actually straightforward? Okay, so we split it. And we do the same with this one, which was here, and then with this one, we split it, and this we split it, okay? And eventually, we have all the stories contextualized. And that's from client's perspective. Again, how good client actually understand their requirements, okay? And then we do the same from the capability context. And capability, it's our software development capability, okay? We have some skills, we have some knowledge that we can apply in this new software development project. And again, we have three cases. And because we are software developers, right, the first case is, of course, we have all the knowledge and skills required to implement a certain requirement, a certain user stories. And that's obvious domain. And then the next case is that we do have some of the knowledge and some of the skills. The rest we'll have to research on Google or read books or analyze or maybe find somebody that actually have done it before to help us, right? So it's not clear, but we can do it, okay? Somebody have done it somewhere before, okay? And we are sure we can find how. The next case is actually when we have absolutely no knowledge and skills to implement a requirement. And let's admit there are cases like that, okay? At least in my experience, right, there are cases like that. And we have to admit this, right? And again, we follow the same pattern. We put the three cases in the corners. We place all the same user requirements, the same initial 14 user requirements, and we place them on the board. And then we draw the borders. And then we find something which is in the border between analyze and do. And we split it into two user stories, and then we find something which absolutely we're not sure where to put it, and we split it into one from that requires experiments and one which is straightforward, and this one is again unclear, and we split it in two, okay? So now we know We choose our stories, we have no idea what to do at all, how to approach it, okay? In this case, there are 4. We have some which are straightforward, and we have some which is normal work. I mean, analysis and analyzing stuff, it's for experts like us, that's normal work. And then we place the client in capability context, and we have a discussion with the client and say, well, here are things that you don't know what actually you want to be implemented, and here are some things that we don't know how to do, right? And that's the social part, that's the tricky part, but eventually, from my experience, clients like this, and software developers like this, because it makes everything more honest, right? And much more clearer. And after that, we categorize based on, like for each user story, we want to actually have a certain category, which means that if it is complex in one of the domains, we say it's high uncertainty. If it's obvious in both of domains, it's low uncertainty. And if it's complicated in any of the domains, it's medium uncertainty. And this is just to actually make both contexts like as one together. And then what's important is that when we do this initially at the start of the project, we cannot actually leave it like that, because we learn. Remember, we are a complex adaptive system, and the client is part of the system. We learn, and we change our understanding, so that we should probably constantly change the user stories from experimentation into analysis, or from analysis into just work, right? And it has, especially when we have new user stories, for each new user story, we have to actually contextualize it. Because we have the context, we say, oh, this is high uncertainty, or medium uncertainty, or low uncertainty. Now, something about scheduling, right? So scheduling is different. Being uncertain and being long is different things, right? Just for us to understand, yeah. So here is a histogram of a user story that we think can take from 1 up to 15 days, and that's the medium. Median means like we have 50% chance to be less than 5 and more than 5 days. And that's the same thing for another user story. Again, maximum 15 days, but median 10 days. And here is something which is really, that's very much certain, no uncertainty. Again, up to 15 days, okay? So this is high uncertainty, this is medium uncertainty, and this is low uncertainty. So in Scrum especially, there is this tendency to, when using story points, what actually story point means? Does it mean the user story is uncertain, or it will take longer, right? And people conflate from time to time the two. And here we're talking not about how long it will take, but how uncertain it is. Do we know what to do, okay? And then in execution, what we actually do, we try to move all the user stories which are in the complex domain into complicated, or maybe into obvious, even into obvious. So what we do experiments here. In Scrum, we call them spikes in Agile, right? We do spikes here. Hopefully, with the hope that they will move here, we will be able to analyze and eventually implement the requirement, okay? So that's a cycle, constant cycle, okay? So yeah, okay, complex, I'll have 7 minutes. So here we come about the metrics, right? Because we started with a burn-up chart, and a burn-up chart is a form of measurement, right? So this is very important. I would like to take with you from this session. So metrics such as delivery rate should be looked at in context. I mean, our understanding of what we have measured, right? Because here, what actually happened back then was as follows. So this is a project that in year 2011 implemented a chat bot on Facebook for a recruitment company, global recruitment company. And the chatbot allowed people who apply, who look for jobs, to type in Facebook Messenger. It was back then, it was not called Messenger, but what was the Facebook Messenger, type something like, I am looking for a Java developer job in Istanbul. Do you have any? And then there will be a reply saying, well, we do have some jobs in Istanbul for Java developer. Please look this list. And then there will be, show me next jobs, show me previous jobs, and then you will be able to actually click on a link and then apply for the job in Facebook. But the important part was this chatbot. And back in 2011, there were no frameworks for building chatbots. So what the team actually did here for close to 3 months is actually to understand the problem. First of all, what the chatbot was supposed to be doing. Then test different technologies, how to actually implement this chatting functionality. Okay? Back then, there was no artificial intelligence, nothing like that, right? And it was implemented. Eventually, the team settled on using Spring integration as a backend. And for the chatting technology, for the artificial intelligence part, there was a framework which is actually is discontinued, like it was very old framework. But that's what the team did for 3 months. And then when they decided on the technology, that's what happened, right? They did all the work like very much faster. And that's, I guess, you have at least one project with similar experience, right? And can we call this project agile? I was there, right? I was leading the project, like one of the developers, even I have code here. So for me, it is the quintessential agile project because we started with a high uncertainty. Very high uncertainty. But we managed actually to move the user stories from complex into complicated and obvious domains, right, and eventually deliver. And that's a quintessential agile project. But from the outside, it's not predictable. But from my point of view, it's very predictable because with this team, I can tell you that next project, they will indeed follow a similar delivery curve, right? They will be able to adapt to the new technology, okay? So, takeaways. So this is something important like for you, for me, and that's why I'm coming here to share, right? We need to be predictably adaptable. There's no need to put labels and follow frameworks like Scrum, Kanban, whatever, SAFe or whatever. What we have to do is to be able to adapt predictably. We need to know the context, what type of problems and situation we're dealing with, so that we can act accordingly and be able to explain why we did so, why we don't have this delivery rate like straightforward. Okay? Experiments are needed to handle requirements which are not clear. That's everybody knows this, okay? But you have, if you go to a customer and say, well, I'll need a couple of months for experiments, and they say, well, and that's my experience, right? Hopefully yours. And the client would say, do you tell me that you don't know what to do and you expect me to pay you for this? I told that you are an expert. That's why I'm here, right? And then hopefully you'll be able to explain, yes, we are expert, but for certain requirements, it's not about expertise. It's about finding our way, complex stuff, okay? And then the most important thing, changing complex problems to complicated increases predictability in software development, okay? So that's what I wanted to show you, right? So being agile is to be predictably adaptable or to be able to adapt predictably. And if you look at the Agile Manifesto, that's what they say, right? And that's all the things that we say about team dynamics, team collaboration and everything. It's everything around the same thing, but hopefully I managed to show you how actually to use a specific language in order to explain to your clients and project sponsors why you need to do certain things and why it is indeed agile. So we have 20 seconds for questions. I'm not sure. I'll be outside. I'll be at the conference for the whole day. So if anybody has questions, because we don't have time, and hopefully I provided you with something practical. Okay? Thank you very much. Teşekkürler.